Okay, everybody, welcome back. I know everybody's taking a break. I decided not to take a break, and I'm going to post this, all right, and then you guys can work on it maybe over the weekend or on Monday, but there is just no time to waste. So I want to go ahead and get everything that I need to get done, which means I'm not taking a day off. All right, so with that, today we're going to learn how to solve a quadratic using the quadratic formula. All right, it's just another technique. All right, and you use this technique when you can't factor it. So for example, if I look at question number 1, I cannot factor that. So they had to figure out a way to solve that without using factoring or without taking the square root. So they figured out this great formula, all right, which is called the quadratic formula. Now, at this time, I can't derive that for you, all right, but next week, I'm going to show you how they came up with that formula when I teach you how to complete the square, all right? Maybe I should have completed the square first, but the quadratic formula is just that much more important than completing the square. So what I want to do now is I want to show you what the quadratic formula means, all right, and how to apply it. All right, now the first thing I want you to do is write down y equals ax squared plus bx plus c. That's what we say is the equation for a quadratic. Now, what we want is we don't want the graph, we just want how to solve it. And when you solve it, that just means you're going to set it equal to 0, all right? Now notice a is the number in front of the x squared term, b is in front of the x, and c is considered a constant, all right? So what the first thing we're going to do is on number 1, we're going to write down that a equals 1, b equals -1, and c equals -4. Now, how do we get that? All right, again, just to demonstrate, the number in front of the x squared term is a, right? Then there is a -1x, all right, which we would say that number is the b value, and then we would say that c is -4, all right? Now, all you have to do is understand that, and once you understand that, it's just a matter of plug the numbers into the equation, all right? So I'm going to write it down. Everybody should write it down, and then eventually you'll just recognize, or you'll be able to recite it. -b plus or minus square root b squared minus 4ac all over 2a. So x is equal to -b plus or minus the square root of -1 squared minus 4 times a times c all over 2 times 1. All right, now it's just a matter of simplifying. X equals 1 plus or minus square root of 1 plus 16 all over 2. So x is equal to 1 plus or minus the square root of 17 all over 2. Now, again, that's it. That's how easy. All right, super, super, super easy. Just a matter of plugging numbers into a formula and simplify the formula. Now, if you recall, the square root of 17 cannot be broken down. So that's one thing we have to keep track of. We have to make sure that it can't be broken down. All right, and we'll see that later. All right. So let's go ahead and take a look now at number 3. So again, the first thing, a equals 3, b equals -11, c equals -2. So now we say x equals -b plus or minus square root b squared minus 4ac all over 2a. X equals negative b plus or minus negative 11 squared minus 4 times a times c all over 2 times 3. So x equals 11 plus or minus the square root, negative 11 squared, 121. 4 times 3 is 12, times 2 is 24. Two negatives make a positive, so plus 24 all over 6. So x equals 11 plus or minus the square root of 145 divided by 6. All right. Now, again, we have a final answer. However, we do want to double check to see if 145 can be broken down. All right, so just to review that, we're going to take 145 and see if there's a perfect square. 5 times 29. Neither one of these is a perfect square, so the square root of 145 cannot be broken down because these are prime numbers. So guess what? So that's your answer. All right, this x equals 11 plus or minus the square root of 145 all over 6. Just plugging numbers into a formula. Okay, now let's look at number 5. Again, a equals 6, b equals 4, c equals negative 1. I encourage you always to write out the equation to help yourself learn it. X equals negative b plus or minus square root b squared minus 4ac all over 2a. So x equals negative 4 plus or minus square root b squared minus 4 times a times c all over 2 times a. X equals negative 4 plus or minus square root 16 plus 24 all over 12. X equals negative 4 plus or minus square root of 40 over 12. Now we have to think back and we have to see that 40 can be broken down. So let's review that process. Negative 4 plus or minus 40 is 4 times 10. And now we say that the square root of 4 is 2. So we can now write it as negative 4 plus or minus 2 radical 10 over 12. Now we're almost done. Final step now is to take a look at the 4, the 2, and the 12, right? And decide whether we can reduce. The reason we can reduce is because all 3 of those numbers are divisible by 2. So after all that, my final answer is negative 2 plus or minus 1 radical 10 all over 6. So again, I divided by 2, divided by 2, and divided by 2. Now, is it necessary to write the 1 radical 10? And the obvious answer is no, it is not necessary. All right, so I can kind of erase that. Okay. So again, that's the demonstration of solving using the quadratic equation. Now again, you should say to yourself, that wasn't that hard. It's just a matter of identifying A, B, C, then knowing the equation, plugging the numbers into the equation, simplifying the arithmetic, and then you ask yourself, can I simplify the radical? All right, very simple. Let's check out number 7 now. Same process. I want you to identify a equals 1, b equals 6, c equals 3. Write the equation. X equals negative b plus or minus square root b squared minus 4ac all over 2a. X equals negative b, which is negative 6, plus or minus the square root. Now, 6 squared is 36, minus 4 times 1 times 3, all over 2 times 1. Simplifying, negative 6 plus or minus square root 36 minus 12 over 2. X equals negative 6 plus or minus square root of 24 all over 2. Now, again, we're looking at this 24, simplifying. X equals negative 6 plus or minus 2 radical 6 over 2. Now again, if you're going, how in the world did you get that? Remember, 24 is the same as 4 times 6. Square root of 4 is 2. So there you have the 2 radical 6. Now we're looking at this saying 6, 2, and 2. Can all 3 be divided by 2? So our final answer, negative 3 plus or minus 1 radical 6 all over 1. So we can just say this is our final answer, negative 3 plus or minus square root of 6. Final answer. So hopefully you're getting the hang of it. All right, now let's take a look at number 9. Now, occasionally you might want to just pause the video, see if you can do it on your own, and then restart the video and see if you're getting the same thing as I am. So number 9, a equals 2, b equals negative 10, c equals negative 1, x equals negative 10, which is 10, plus or minus negative 10 squared is 100, minus 4 times 2 times negative 1, all over 2 times 2. So x equals 10 plus or minus. So this is 4 times 2 times 1 is 8. 8 plus 100, 108, all over 4. Now 108, you have to remember, is 4 times 27. So the square root of 4 comes out as a 2. So again, x equals 10 plus or minus 2 radical 27 over 4. Again, dividing by 2. So x equals 5 plus or minus 1 radical 27 over 2. Okay, so now those are really good examples. Those are 5 really nice examples for the quadratic formula. All right, now you can go ahead and try the evens, but we'll talk about them next week. I'd really like you to just concentrate on working through the odds. Now, what I decided to do next was, okay, you get to decide which method, all right? We have a square root method, we have a factoring method, and now we have the quadratic formula, okay? So those are the ways. So what I'm going to try to do now is I'm going to try to go down and show you how you would decide which method to use. Now, the first one I tried to make easy because I would just want you to recognize, because there is no x term, we can just say we're going to take the square root of both sides. All right, so we take the square root of x squared is x. Now the biggest mistake kids make is they forget the plus or minus. So the answer is plus or minus 5. Now keep in mind, this is how I remembered. That has a power of 2 So I automatically knew there were 2 solutions. Okay? Now, number 13. Number 13, before I start out and do the quadratic formula, I just say, hey, is this an easy factoring problem? And guess what? This is an easy factoring problem. So I would not do the quadratic formula for this. I would just do 2 sets of parentheses, and I would say x times x. Then we'd say the factors of 12 that make 1, 4, and 3. But I want -1, so I want the 4 to be negative, the 3 to be positive. Now we set the factors equal to 0. So x is equal to 4, or x equals -3. Okay? Now what? All right, let's check out number 5. All right, now once again, I have a single square term. All right, and how do we undo a square? We take the square root of both sides. Take the square root of both sides. So with that, we're going to do x minus 5. Now, let me just refresh you. A square root and a square cancel each other out. Remember, when you take the square root of a variable, I told you the most important part to remember, and everyone forgets, is that it's always a plus or minus. Okay? Now we have to isolate the x. So the next step is to add 5. And you can't add the 5 is irrational and square root of 6 is irrational, so we cannot add them together. So we say x is equal to 5 plus or minus the square root of 6. Okay? Now, 17 is an interesting problem. The reason why I say it's interesting is because everybody knows now to solve a square, we take the square root of both sides. When I take the square root of both sides, the first thing you should notice is there's no number when I take the square root that will equal a negative. So you have to put a star by this problem. And you have to remember, because the inside of the square root is negative, we say there is no solution. All right, no solution. All right, now let's take a look at 19 now. So for number 19, it's another quadratic raised to the second power. So again, if I try to factor it, there are no factors of 9 that will make 3. So we want to do the quadratic formula for this one. Okay? So remember, x equals -b plus or minus square root b squared minus 4ac all over 2a. So x equals -3 plus or minus the square root 3 squared, which is 9, minus 4 times 1 times -9 all over 2 times 1. Now, it's not that I made a mistake, but I just want to make sure that you remember a equals 1, b equals 3, and c equals -9. All right, now we're going to go ahead and simplify. X equals -3 plus or minus. Now, this right here is 36. 36 plus 9 is 45, all over 2. However, 45, if you recall, has a perfect square. So I'm going to review that with you. -3 plus or minus 9 times 5. And then we say the square root of 9 is 3. So I have -3 plus or minus 3 radical 5 over 2. All right, and again, that is considered our solution. All right, that is considered our solution. Easy as that. Okay, number 21. What I try to do on 21 is I try to fool you, because not all equations are quadratics. So what I want you to do is treat this just like a normal equation. All right, you're going to distribute, so that'd be 4x minus 10 equals x plus 2. Move the x to the left side, add the 10, divide by 3, so x equals 4. So again, make yourself a note, no, not a quadratic. Technically, this is called linear, all right, because it's x to the first. Quadratic is defined as x to the second, okay? Let's see about number 23. All right, now 23 is interesting. All right, the reason why I can't take the square root of both sides is because you can't take the square root through addition. All right, what I want you to look at now is, and we've done this in the past, we're going to have to actually multiply this out. So let's look at it. X minus 5 times x minus 5. X squared, negative 5x, negative 5x, and then plus 25. All right, so this is x squared plus 9 equals x squared negative 10x and plus 25. Now the reason why this one's nice is because look what happens. The x squareds cancel each other out. So it's not really even a quadratic. After we simplify, it becomes linear. So now we're going to subtract 25 from both sides. We're trying to isolate the x. So I have negative 16 equals negative 10x. Divide by negative 10, and we just reduce the fraction. So I reduce that to positive 8/5. Right? Now, 25 is kind of annoying because, again, I got to multiply this out, distribute the 2, which creates a quadratic. But then we've got to set the quadratic equal to 0. All right, so this one is challenging. So I want to make sure you stop the video, take your time, look it over. Very important. Okay, so now we're going to multiply x plus 6 squared. Remember, x plus 6 squared, all right, x squared, positive 6x, positive 6x, and a positive 36. It's combined terms. So it becomes x squared plus 12x plus 36 plus 2x minus 2 equals 13. All right, now what I'm going to do is combine like terms. So x squared, just to show you what I mean, 12x and 2x is 14x. 36 minus 2 equals 13. Now, because it's a quadratic, we're going to set it equal to 0. So now I have x squared plus 14x plus 21 equals 0. Now, again, the annoying thing here is the numbers are kind of big, and this doesn't factor. All right, so we're going to use the quadratic formula again. Remember, how did I know it's quadratic formula? It didn't factor because the factors of 21 are 1 and 21, 3 and 7, and none of those factors make 14. So here we go. Let's look at this now and say a equals 1, b equals 14, c equals 21. So write the equation, negative b plus or minus b squared minus 4ac all over 2a. Okay, let's move this out of the way. And now we'll simplify going across. So negative 14 plus or minus, of course, 14 squared, 196 minus 4 times 1 times 21 all over 2. So now I have negative 14 plus or minus square root of 196 minus 84 all over 2. So now negative 14 plus or minus square root of 1, 1, 2, or 112. Okay, all over 2. All right, now what I need you to do is remember that 112 is 4 times 20. Oh, it was 16 times 7. I just remembered. 112, sorry about that, is 16 times 7. Now why? Because I want 16 to break down. So negative 14 plus or minus 16 times 7 over 2. Negative 14 plus or minus, remember the square root of 16 is 4. So 4 radical 7 all over 2. Now we can notice that this is divisible by 2, this is divisible by 2, this is divisible by 2. So we can just say, after all that, negative 7 plus or minus 2 radical 7. Okay? Okay, a couple more to go, guys. 27 and 29. All right, then I want you to stop the video, then go back, rework the problems, and then we'll do the evens the next lesson. Okay? So over here, we have a quadratic, but first of all, I need to get rid of the dividing by 3. So I'm going to multiply both sides by 3. So now I have x plus 4 squared equals 24. Now I can do what? Take the square root of both sides. So x plus 4 is equal to plus or minus the square root of 24. However, I do remember that the square root of 24 can be broken down, right? 24 is equal to 4 times 6. So when you break it down, it's 2 radical 6. So x plus 4 equals plus or minus 2 radical 6. Then we subtract 4 from both sides. And once again, I'm just stressing, this is a rational number. This is irrational, so you cannot combine those. So you just say x equals negative 4 plus or minus 2 radical 6. Okay? And you're done. Last one. All right. Now I notice on this one that there is just a square term. So what I want to do is I want to isolate it by adding 6. So 3x squared equals 30. Divide by 3. X squared equals 10. Now I do what? Take the square root of both sides. So x is equal to plus or minus the square root of 10. All right? So let me make this perfectly clear. Right? This is the class that was supposed to happen on Friday, but since you guys, official announcement is there's no school and there's a long time, all right, I didn't want to take that much time off of school. So I want you guys over the weekend to try this. I want you to try it on Monday. And then the next class, I'm going to expect this to be done, the odds. And then I will go again with you slowly over the evens, and then you'll have a better understanding of solving a quadratic using the quadratic formula, as well as all the different possible techniques. And the only thing I need to show you is how to solve a quadratic by completing the square. And then, believe it or not, we will be done with quadratics. I'm going to give you a little quiz, let you go through it. And then the last thing we're going to do is rational functions. Okay. So with that being said, I hope everybody's staying safe and healthy. I miss you guys very much, and hopefully we'll be back in the classroom soon. But if not, have a great Easter break, and don't be afraid to get some work done and make sure that you understand this. For those of you guys that I'm just trying to make sure that you have a good foundation for algebra.